In this video, I will provide a simple illustration to roughly understand what a gravitational wave is. First, I will talk about mechanical waves very quickly. Mechanical waves, like sound, like seismic waves, they propagate through a material medium, which is important, in contrast to electromagnetic waves and gravitational waves. So, in your mind, three types of waves, okay? Mechanical waves, like, for example, the voice, and electromagnetic and gravitational waves, on the other hand. Because electromagnetic and gravitational waves travel through the universe, unlike mechanical ones. Electromagnetic waves, as you know, the best example is visible light, but there are also invisible waves, like gamma rays, X-rays, ultraviolet, visible light. Then infrared. So all of this is in increasing wavelength, and then the waves, microwaves, then radio waves. These are electromagnetic waves. And for gravitational waves, what are they? Gravitational waves are a deformation of space-time. According to Einstein, it's an oscillation of the deformation of space-time. And the simple image to understand this is to imagine a trampoline. And on this trampoline, you will bounce a very, very heavy ball in the middle of the trampoline, for example. And imagine that there will be waves on the surface of this trampoline. Those waves, those oscillations are gravitational waves. And gravitational waves are actually very weak. There was a revolution with electromagnetic waves. They were discovered by Maxwell in the 1860s. In fact, it had also been initiated thanks to Galileo. Galileo, who, thanks to the improvement of the astronomical telescope, the electromagnetic telescope, basically, he had demonstrated, he had seen the 4 largest moons of Jupiter. And in fact, he had precisely used electromagnetism for that light. And so that's the first revolution, actually. But the second revolution is more recent with gravitational waves. It's that, in fact, Stephen Hawking was very interested in it. His colleagues as well, and notably the American Kip Thorne. And this colleague, precisely with other colleagues, in fact, I can't remember the name, it's Paris something anyway. In any case, they managed to highlight gravitational waves. However, these gravitational waves are extremely weak because they are very, very far away. For example, the gravitational waves that were detected in 2050 with a kind of double detector with 2 different locations in the United States, one in the northwest and one in the southeast. They detected the gravitational waves emitted by a black hole located 1.3 billion light years away from us. And in fact, gravitational waves are typically emitted by celestial objects like black holes, which in themselves actually have a lot of disorder in them, have a lot of entropy in them. They emit gravitational waves, and consequently, according to Kip Thorne, gravitational waves are the best tool to understand the universe, actually, because these are signs that the universe sends us, especially about the beginning of the universe, because these electromagnetic waves travel through the universe. For example, in a black hole, typically, in most black holes, there is no light because of the gravity of the black hole, but there are gravitational waves. So, remember the trampoline, and I wish you a wonderful evening. And precisely, in the trampoline example, the trampoline mat represents space, and not time.